Hello, today we'll be going over Codeforces round number 645 division 2 problem B, which is Maria breaks the self-isolation. So in this problem, you're given n and n integers, and what these integers represent is how many grannies have to be in a courtyard in order for the granny to join. So you start out with one granny in the courtyard, which is named Maria, and then each of these numbers represents a granny, and the number value represents how many grannies have to be in the courtyard for the granny to join. So for example, here, we see that there must be one granny in order for this granny to join. Same over here, there must be one granny. So the goal which we want is to find out the maximum number of grannies that can go in the courtyard. So in this case, what we would want to do is that we want to put these two grannies, marked with 1, into our courtyard. So we'd have 3 people in our courtyard. Next, we would look for anything that has a number value of 1, 2, or 3. But here, we see that the minimum we have is a 4, meaning that there has to be at least 4 grannies in order for this to join. However, there's only 3 grannies. So in this case, what we can do is we can take a subset of the grannies. We take grannies 5, 4, and 5. And adding this, we get 6 total grannies in the courtyard. In this case, 6 total grannies is greater than 4 and 5. So this works. So we can either take an individual granny or we can take a subset of any size of the grannies. And the last element we see here is a 9. However, we see that we have 6 people in the courtyard right now. So we can't possibly add this last person. So therefore, our answer becomes 6. So before we start, there's one key observation which we can make, which will lead us to our solution. So in our example, we picked the grannies numbered 1 first, then we picked 4, 5, and 5, and then we picked number 9 last. So in this case, we picked the grannies from smallest to greatest. And smallest to greatest meaning that the amount of grannies required in the courtyard for the ith granny to join is the smallest. So the reason why we did this is because we want to add the maximum amount of grannies as we go up to the bigger numbers. First, we're going to keep doing this and compare all of these bigger numbers to the amount of grannies already in the courtyard to see if we can add them. This maximizes the amount of grannies we can have in the courtyard. So let's go over this. First thing we have to do is sort the array, smallest to largest. Now that the array is sorted, we can keep a variable, granny counter, equal to 1. And the reason why it starts out as 1 is because we start out with 1 granny Maria. Now we start going through the array left to right. We start here. We see that a of I is equal to 1. We check the granny counter. There is 1. So we compare it to the granny counter, and if a of I is less than or equal to granny counter, we can add it. So now granny counter becomes 2, and we added this one. Then we check over it, we see another one, it becomes 3. But now we check the 4. 3 is less than 4, so therefore we cannot add it. But in the actual solution, we could have added it. So let's go over how we can solve this. In order to keep track of this, we can set another variable, temp var. Now, what this temp var variable is the maximum amount of grannies we can fit at a specific point. So let's say we're at this point, where we're at the position 4. The maximum amount of grannies we have stored as of right now is 2. So we store that in temp var. Now we check the 4. So now we're going to do a little bit of experimentation out here. We're going to assume that we add this number 4 granny. So then granny counter becomes 4 now. And then we're going to assume we add this granny over here, and then granny counter is gonna become 5. And then we're going to assume we add this granny over here with the granny counter equal to 5. And now we can add this granny because granny counter over here is equal to a of I. So therefore we can add this 5 and granny counter becomes 6. So then once we arrive at this point, once granny counter is less than or equal to the total counter, we can stop here because we have a 5 here, which is less than or equal to a 5 here. So we have temp var equal to 4, and then after that, we continue this one section over here, and then temp var becomes 5 because we add this one extra granny, and then we go over to the 9. The 9, however, even if we assume to add a granny, Remember, we stop here. If we assume to add a granny, granny counter becomes maximum 7. However, 7 is less than 9, and since there are no more grannies, we can stop there. So now we have temp var equal to 5. However, we have to add 1 to temp var because we are not including Maria at this example. We're just including the amount of cows we have added to Maria. So we add 1, 5 plus 1 equals 6, which is our final answer. For the code part of this solution, we can start out inputting t, the number of test cases, and for each t we'll input n, the number of grannies, and create an array for all the grannies. Once we have done this, we want to sort the grannies array from least to greatest. Then we want to create two variables, a granny counter and our temp var. Then we're going to go into our for loop. Inside here, we want to check if the granny at position I is less than or equal to counter. Then we want to set temp var equal to I plus 1. And remember, temp var is the amount of grannies added, excluding Maria. Temp var will continuously be updated in this scenario. Because temp var will store the maximum amount of cows at a single point in time. Now remember, in our solution, we want to continuously add a cow even if gran at position I is greater than counter, because in that case we can check if a subset works. So we're going to add counter each time. From there, we're going to print out temp var plus 1. Remember, temp var is the maximum amount of grannies that will be added to the courtyard. The courtyard also includes Maria, so we add 1 to temp var. Then we can return 0. Make sure to have this ENDL at the end. Submitting this shows that it is accepted.